Alrighty. So I'm here alone. Just finished my advanced pre-maths class not so long ago. And a student asked me to work out this paper. This is the exam paper from today. It's May 9th, 2025. And what he said is that a number of courses were out online. But she wanted to see my solution. I would have worked out anyway, but I normally do. Work out these papers as a teacher. You need to work out these papers. So, see what CSEC is all about. Standard of question, keep abreast with what they're doing. All right, so this is the exam from today. Most students said that it was nice and easy. It was soft, a capital T. So let me see for myself now. All right, somebody sent me, and I'm gonna run through it. It's a good class, but I'm not really teaching, just running through the paper. All right, so I have a calculator on the screen. First part, as usual, is to use a calculator, or otherwise evaluate the exact value of this thing, exact value in exact form. All right, each of these. All right. So as a matter of putting this in the calculator, it says using a calculator, so we can use a calculator. So this is 3 over 2 squared. So I'm gonna bracket it just like as it is there. Put it 3 over 2. Close the bracket, square it, minus 1 plus 6. That is 7.25 in exact form. 7.25. What do you mean by exact form? The exact form is something in giving your answer in exact form. Exact form is something I need to research that. 7.25 in exact form. I don't remember what exact form is, but this is that. 7.25. 1 mark for that. This one, same thing. I'm gonna put it in the calculator. And I'm gonna get 2.1 times fraction 10 over 7. Close that bracket, plus 12 divided by mixed number 1 and 2 over 5. Within 10.5. Exact 10.5. Exact form. Let me take a quick look and sort the exact form. I don't remember what exact form means. Exact form in math. That is not a decimal. That is side of an approximate value. After involved function. That is it. Exact form. And if there's more, nothing special. 2 marks for this. I don't understand. That is it. Next question. It says Miranda earns this amount per month. She spends 4/7 of her earnings on utility, food, and personal items, and she saves the remainder. Now the remainder has to be 3/7. So the remainder that is saved is 3/7 of the total. All right? That's 4/7, you need 3/7 to complete the total. 7 parts. It says what percentage of her monthly salary does she save? So this 3/7, they want as a percentage. That is R. So it's 3/7 multiplied by 100. And you get that as a percentage. Right? So it's here is as a fraction, as a percentage, you multiply by 100. So it's 3 over 7 multiplied by 100. So that's 42.9%. 3 significant figures. All right, 1 mark for that. Next part says, portion of our earnings spent on utility, food, and personal items is divided in this ratio. The total parts on this ratio right now is 14. Nice number for the same, right? 14 is the total parts on this ratio. That's 14, right? No, not 14, as I might say. Not 14. It's 12. It's 12, 9 and 2, 12. Not 14. So the total parts on this ratio right now is 12. 12 total parts. All right. And she says, calculate the amount of money spent on personal items. Personal items is the one in the utilities, food. Personal items come third, so third part, so it's 412. So it's 4 to 12 times the amount that you actually save and that the amount that you spent on these things, which was 4/7 of the amount of money, right? 4/7 of the total 8316. 8316. 8316. So this is the amount of money that was allocated to these things. And in that breakdown, she's spending 4 out of 12 parts on personal items. So it's 1/4 of this, 1/3. 4/7 is 1/3. That is the calculation. So it becomes 4/12 times 4/7. Times the total amount 8316. That works out to be $84. All right, there was the total parts in that ratio, and the third part of the ratio is the personal items. Exactly the amount of money spent on the personal items. That's 4 out of 12. All right. That's it. Next part says she saves same amount of money each month. Show that her annual savings is this amount. So we need to find out how much she saved each month, right? Now remember, she saved 3/7 of the amount. 3/7 of the amount. And that's for 12 months. Right? So that becomes 3/7 times the amount was 8316. 8316. That's the amount that she's saving each month. And we have to multiply this by 12. So it's 12 times that amount, because there are 12 months in a year. Right? Annual means in a year. So this calculation is supposed to give us this if we are correct. So let's see. So it's 12 times 3/7 times 8316. Voila, beautiful. That's 42768. That was shown. All right, nice. This part says she invests this amount, the same amount that she saves. She invests in a credit union which pays compound interest, 5%. So each year the new value is going to be 105%. And that's per annum. What is the total interest earned after 2 years? All right. Or they give us a formula here for the total amount earned. So this is the final amount A, when the principal is P, invested in compound interest at a rate of R for N years, is this formula. So this formula will give you the total amount that she has. That is the total interest earned. Wow. Have to be careful. This is the total amount in there, but here they want the total interest. What is the total interest earned after 2 years? So total interest earned is going to be the total amount minus the amount that she had in there and that she started with. To be careful with this calculation, guys. This is going to give you the total amount in there. But what they want is the interest. We're going to have to subtract. So we read the questions carefully. I think this will get a lot of people in this particular question. So the amount in there after 2 years, you know, what does that mean? That the n is equal to 2. Based on the 2 years, the r is equal to 5, because this 5% is taken care of here. The 100 on the year is taken care of the percentage. So the r in this expression is 5. And the p is the original amount invested. The p is that amount of 42,768. So the interest is going to be the amount minus the principal. The total amount in there minus the principal. All right? So this is the total amount. See, final amount is that this amount includes the interest. So the interest is what they want. It's going to be that amount minus the principal. And the amount is basically this calculation, which is the principal of 42,768 into 1 plus 5 over 100 squared. That's what we plug these values inside this formula. That's the total amount, and you're going to subtract now the original amount, because we only want the interest. I think this question is going to get a lot of people. A lot of people is going to calculate the A and think that is it. But we want just the interest. All right, so we have to subtract the 42,768. All right, and do a calculation. Yes, let's do it. Let's put everything in the calculator. It's 42,768 times bracket. This really becomes 1.05. We can put it as you say, 1 plus 5 over 100, close the bracket, square that for the 2 years, then subtract the amount that was invested, 42,768. All right, and so the interest is simply 4,383.72. I really believe this question is gonna get a lot of people, but they're not gonna realize that they want the interest. Particularly the word total might get them. All right, they want the interest, not the total amount earned, not the total amount in the account. All right. This formula, remember, is for the total amount that is accumulated. All right, so that is the answer right now. Let's continue. Don't even need to calculate for this part. All right, so this now wants us to factorize. The students join. Let's invite them to join. Let's see. So one person. Anyway, so this now wants us to factorize completely this expression, right? So there's a common factor factorization. So here we're looking for a common factor in terms of the x, and the x squared common factor is x. So that the y squared and the y common factor is y. So dividing xy out of this, we're going to be left with just y minus dividing xy out of this, we're just going to be left with x. Double check it. This time this give about that. Yes, it does. And this time this gives about that. Yes, it does. So, and then this can be factorized any further. All right. That is it. XY factor out. Next one. That's a quadratic to factorize. When the first values are prime, it's kind of easy to factorize, but that's only factors of 3x can be 3x and x. I'm just going to factorize it straight. That's 3x and x. Then we want factors of 10, such that the far product and the near product gives you this middle term. All right. So I'm going to put 2 and 5. 2 here, 5 here. Then the far product is going to be 6x, near product is going to be 5x. This minus here tell me that I want the difference between the near product and the far product to be the middle term, which the difference between 6x and 5x is 1x. And then the larger product must have the positive sign. That's what the plus here means. The larger product is the far one, so I put in the plus here and the minus here. Those are two factors right there. If you want to run through the process of doing the length way to do it, then fine. But also double check. This time this is 3x squared. Then the minus 5 times 2 is negative 10. And the far product is 6x and the near product is minus 5x. These two add to that middle term. So you can accept that this factorization is correct. All right, in any order. Next part wants us to solve for n, which is indices. Right? So these were dividing these two. When you divide indices, you subtract the power. So this side becomes 4 to the n minus 3. 4 to the n minus 3. And then now this 1 over 4 is same as 4 to the negative 1. 4 to the negative 1. That's 1 over 4. All right. It therefore means that these two powers are equal. But the two bases are equal. So we can conclude that n minus 3 is equal to negative 1. Transpose the negative 3. We get the n equals 3, positive 3 minus 1. So n is equal to 2. That's the answer right there. N is equal to 2. I'm thinking of if there's another way to do it without using that negative 1. Thinking of another way without using that negative 1. Let me see. We could maybe do is write this as a fraction. 4 to the n over 4 cubed equals 1 over 4. And then sort of cross multiply. And we would have gotten, cross multiply over here, would have gotten 4 times 4 to the n equals multiply this over here, would have gotten 4 cubed. Then this 4 times 4 to the 1, if you want, you could work out what 4 cubed is. You work out that as well, work out the actual value of this 4 cubed. I've done that way as well and work out that actual value, but anyway, keeping it as an indices question. So this 4 is same as 4 to the 1. Right here now. And so we are multiplying 4 to the 1 times 4 to the n. So you're going to be adding these two powers. So it becomes 4 to the 1 plus n equals 4 cubed. Come back to the same thing. This 1 plus n is now equal to 3. So we'll get 1 plus n equals 3. Transpose this 1. We get n equals 3 minus 1, just the same. And so n equals 2. So this is a method, this is a way we could have done it. Without, if we did not know that the reciprocal is actually 4 to the minus 1. All right, so that is that. All right, let's continue. This part now says, Josiah, can you hear me? Can you see the screen? Josiah? No response. All right. Question says, the length of 3 sides of a trapezium are shown in the diagram below. So that's a trapezium. I see the 90 degrees here and here. In that these are the 2 parallel sides. It must be parallel because these 2 interior angles are 80 degrees.
You must say if you can see the screen.
Mute the mic, please. Can you see the screen? You can see the screen?
Yes, yes.
All right, let's mute back your mic, please. Mute back your mic. All right. So these are the 2 parallel sides. And this is the perpendicular distance between them. All right. Question says, write down an expression in terms of P and Q for the area of the trapeze. All right. So the area would be half the sum of the parallel sides, which is 4P plus 3q multiplied by the distance between them, which is 6p. That's an expression for those two, the area. And this can be simplified because we're able to multiply this half by this 6 and get 3p. So we get 3p into 4p plus 3q. And this can be further simplified. This can be further simplified or can be expanded out. And this time this will give us 12p squared. And this time this will give us 9p cubed. So what I feel if you left this, don't give it the answer just the same. They give it a mark just the same. You don't know 1 mark. So that is it. Next part says, given that q is equal to 2p, determine the value of p. Remember, it told us that this area is actually equal to 750. That's what I said in the question. So to find the p, we're going to have to equate this expression for the area with it 750. All right, that's what we have to do. So here we're going to say 12p squared plus 9p cubed is equal to 750. But then the other one that the q is 2p, so we can take this 2p and substitute for the q right here. So then it will become 12p squared plus 9p times 2p, or substitute 2p for this q. That is equal to 750. So this is actually 18, and 2 is 18, so that's 18p squared, and that's 12p squared. 18 and 12 is 30. So that is 30p squared. 30p squared equals 750. So I have to divide this out. So we can divide through the tens first, and we're going to get 3 into 75 is 25. This really reduces to p. This really reduces to p squared equals 25. And then we square both sides, we're going to get p equals 5. And we're only using the positive 5 because p really is a distance, right? A distance can be negative. Normally here, when you calculate square root, you will be considering that p could be plus or minus 5. But because in this case, p is a distance, we're just going to leave only the positive 5. So that is the answer, p equals 5. Next question. It says, use a ruler or pencil to a compass, construct a triangle PQR such that PQ is 9, the angle at P is 60 degrees, and PR is 12. So I always say sketch it before you construct it. So I'm going to put the longest side as the base side, so that's PR. Make that be the 12 centimeters. And then the angle at P is 60 degrees. I mean that we need a 60-degree angle right here. And then Q is somewhere up here. And it says Q must be 9. So up here is going to be 9 centimeters. And then we're going to complete the triangle by just joining this. So our construct, I'm going to leave the part that we are joining in red. So it's the last thing we're going to do. So we're going to construct what is in blue, and then complete it with what is in red. Let's bring up the geometry set to do this. Nice and easy.
I mean, never read the instructions.
Mute the mic, please. Mute the mic, please.
That never they put the paper.
What
Mute the mic, please.
Or paper.
Then we get the geometry set. Where is it? That close it. That close it. Let's get 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 it. Let's do the construction over here for this question. All right, so we're constructing this thing. First, I need to use my ruler to draw a 12 centimeters line. What this thing will fit. Use a ruler, I'm going to draw a 12 centimeters line. Right over to 12. With the ruler, I'm going to construct 60 degrees at this end down here. So when I lock the compass, let's change the color to show the construction lines. Only need 2 arcs for 60 degrees. So only need 2 arcs for 60 degrees. That's the first part. There's the point here without changing the angle on the compass. Rotate over, cross that one. That's going to be 60 degrees. So I'm going to draw a line through here. What I can do is make an arc from now that is 9 centimeters. So let's make the arc that is 9 centimeters. So when I draw the 60 degree, I'm going to get the 9 centimeters same time. Let's put that in blue. I'm going to make an arc that is 9 centimeters. Let's bring back the ruler. Put the compass at that end. And I'm going to open to 9 centimeters out here. 9. All right, let's move the ruler. And then from here, I'm going to make an arc. Oh, I did not lock it. I did not lock the compass. 9 centimeters, lock it. Move the ruler. I'm going to make an arc up here. Because I need my PQ. My PQ is going to be on this arc. That's 9 centimeters. Move this out of the way. I'm just going to draw a straight line through this intersection now. Straight line through this intersection up to here. And that is where my P is. That's 60 degrees. Voila, that is it. So I just need to complete this triangle, this point down to here. And that is it. This is P, this is R, this is Q, this is 60 degrees, this is 12 centimeters, this is 9 centimeters. That is my construction, nice and easy. Alrighty, that's what you do on this side. Don't forget to switch, so that is it. All right, this is for this. So I made an arc here. I made an arc from here. I will have to cross that arc from this point to get that 60. That is it. I made the 2 sides. That's it. That's them done. Next one. This now is a transformation. Transformation. The question says, diagram below shows 2 quadrilaters R and S. Oh, okay, that's an enlargement. R and S. All right. It says where S is the image of R. So the transformation is from this one to this one. There's an enlargement with a positive scale factor and a whole number scale factor. One is positive because the image and the object, they are pointing in the same direction. All right. That's inverted. So the positive scale factor, I compare this side with this corresponding side. This was 1, it was going to 2. So I multiply by 2, so the scale factor is 2. What I need now is the center of the enlargement. Find the center of the enlargement, I need to join corresponding points and extend it. For example, these 2 points, join them and extend. So it's going to look like that, and I extend it somewhere up there. And then I can join these 2 corresponding points and extend as well. Go like this and extend. Looks like they pass through this point. So that is my center of enlargement. And I can check it because remember now, it also scale factor is 2. And so the distance to the image is also double. So for example, this distance here has been doubled to there. You can see this length and this length is the same. All right, so I can confidently say that this is the center of the enlargement. What point is that? That point is 3, 7. 3, 7 is the center of my enlargement, and the scale factor is 2. And so I can describe it when they want. So I'm sure they're going to ask us to describe. There you go. Describe for the simple transformation which map R onto S. R onto S is an enlargement of scale factor 2. And enlargement of scale factor 2 and center. He said it was again 3, 7, 3, 7. Yes, that is 3, 7. Center 3, 7. To describe an enlargement, I could give 3 things. I give the name and the 2 components, which are the scale factor and the center. To describe it fully. Is the word fully there? Yes. Next part says, on the grid on page 12, which is the page of the graph, we have to draw the image of quadrilateral R when it is translated -4, 5. So -4, 5 means 4 to the left, 5 up. So -4, 5 means minus means that you're moving to the left. Or you need to move the quadrilateral without turning it 4 to the left, 5 up. Or you need to see what happens to 1 point and draw by the same shape around that 1 point. So 4 to the left and 5 up. Let's do it in blue. All right. Let's say we're moving this point. Or maybe this point. 4 to the left, 5 up. So let's check that grid. This is 1 unit horizontal, that's 1 unit vertical. So 4 to the left. 1, 2, 3, 4 to the left, 5 up. 1, 2, 3, 4, 5. So this point is coming right here. So that point is going there. Let me get it in color. This shape. And I have to know draw by the same shape around that point, knowing that this point is here. So what do we have? So maybe use this one instead. So that different point. But I don't want these little lines to be in the way. So let's use this point instead. This point. So let's go 4 to the left. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5. 4 to the left, 5 up. So this point is coming here. All right, and then I'm going to draw about the same shape around this point. So this is the vertical section first is here. And this base side is 3 units. 1, 2, 3 units. And this side is 3 units up as well. 1, 2, 3 units up here. And then this diagonal piece closes the shape. Close the shape. That is quadrilateral. All right, let's just check this one. Yes, we're gonna take it down the y-axis. And then from 1, it's gonna go 5 to 6. Beautiful. So that I must confirm. Let's say I must name it something. Let's name it T. I want to put a T on it. 6. All right, done. Next part says, draw the, on the grid again, draw the image of the quadrilateral, same R, and it is rotated 180 degrees about the origin. Remember, 180 degrees about the origin, same as reflecting through the origin. That way you have to try to rotate, just reflect through. So you treat origin like a mirror. Image distance equals object distance. Simple as that. You could use a matrices method as well, because the 180-degree rotation about the origin is -1, 0, 0, -1. And if you apply that to a point xy, it's gonna go to -x, -y. So you could do that as well with the points. All right, but we're just gonna reflect through the origin, this shape. All right, let me take this off. This blue line. It's gonna be the way. All right, let's do it now with the blue line and show what the reflection will do. So this point, for example, one to the mirror, and that diagonal is going to come to here. So this point is coming to here. With the purpose against it. And we move like it. All right. And how can we do the same color and put the points in blue? Don't matter. I move the line out. So this point reflects to the origin, same distance to here. Mean distance equals to object distance to the. And this point comes to the origin. This distance goes to the origin, right back out to there. See, 4 by 1 becomes 4 by 1. Here. All right, and then this piece. This point, I should say, flex through the origin, not flex through the origin, sorry, there. All right, flex through the origin, and it comes to the this distance equals that distance. That point here is coming to here. Then, this point is not the point at all. So it's coming through the origin. Like that. It's gonna go all the way down to all the way down, all the way down to here. Something is wrong. That don't look right. See, I know if I have a ruler, I know it will be much easier. All right, end of the point. So this point is 4, 4. Yep. So you're gonna go to -4, -4 down to here. It's coming to the origin. There, right. All right, so that is the shape that we're gonna get. But a ruler, if you have a ruler in the exam, it's much easier. But that is it. As I said, it could just negate the coordinates, right? So that just take the coordinates of the points and negate them. That's what the reflection to the origin does, or the one with notation with this matrix. Negates the values. So xy point is gonna go to -x -y. So you can see that. For example, this point is 1, 1, it's now at -1, -1. This point is 4, 1, it's now -4, -1. This point is 1, 2, it's now -1, -2 to here. And this point is 4, 4, it's now -4, -4. So could have used a calculation method. This is said to label it M, I think, M. So this is the M right here. That is this. All right. I hope you all got that one right. I'm remembering something that I taught in class, that 180-degree rotation about a point is the same as reflecting through the point. Rather than try to do the rotation, you reflect through the point. All right, for 180-degree rotation. This one now says the graph below shows straight line PQ, is a straight line PQ, and it's a graph what we want us to do. It says find the gradient of the line PQ. We just need to find 2 points, count the rise and count the runs. For example, these 2 points, we just need to count the rise, count the run, going from left to right between these 2 points. to find the gradient. We don't need to calculate. That's, I'm gonna make sure this one box is 1 unit vertical, one box is 1 unit horizontal. So rise this amount, that's 2 units, that's the rise. And run 1 unit, let's run. So the gradient is just rise 2 over run 1. Gradient is rise 2 over run 1. 2 divided by 1 is 2. So gradient is 2. All right, up here. Gradient down here, M. Rise 2 over run 1. 2 divided by 1 is 2. So gradient of that line is 2. Next part says, write down the equation of the line in this form. And we can see the y-axis intercept right here. This is just C right here. C is equal to 1. So we have the M, we have the C, we go to write the equation. So down here, the M is 2 and the C is 1. So it's y equals mx plus c. So the equation is y equals 2x plus 1. 2x plus 1. See if you have that. Nice and easy. 1 mark for that. What is done? As far as says, two functions f and g are given as those. They want g of negative 16 between negative 16 the g function. It becomes 3 times negative 6 plus 2. 3 6 are 18, negative 18 plus 2. Negative 18 plus 2 is negative 16. Done. That is it. Next part, the inverse of g. Inverse of this g. Start by saying g equals 3x plus 2. Inverse it, x becomes 3 times g to the minus 1 plus 2. This is the inverse function. We just need to make it a subject. Transpose the 2, subtract, and then divide the 3. Make g to the minus 1 a subject. So it becomes x minus 2. We transpose the 2, or we divide under this 3. This is g to the minus 1. So we can write the final answer here. G to the minus 1 of x, what I want, x minus 2 over 3. That is the answer. Nice and easy. This is an easy paper so far. Easy paper so far. Next part. It says, show that f of g is equal to this. So this is a show question, so the answer is on the paper. Let's write the two functions so we can have them in front of us. So it is that the f is equal to x squared minus 1 and the g is equal to 3x plus 2. Let me just copy these down on the next page. Move them down on the next page and paste. We can show what form is coming from the function right here. So from that composite function, we're gonna put this means by putting the g into the f. This means g function into the f function. So that all of the g function gonna come into the f function right here with x. That's how it works. Right, so with this gonna making that construct. We're going to result and we're going to expand it out to that. So it's f of g of x becomes 3x plus 2 all squared minus 1. We need to expand it out to this. So we're going to have to expand this first. So the first term squared. First term squared is 9x squared. And twice the product of a 2. So multiply these two things, we get 6x double to 12x. 12x, Mr. Shaw, 12x. And the second term squared is 4. 4 minus 1 is 3. We get a plus 3 right here. We're going to factorize the 3 and get 3 into 3x squared plus 4x plus 1. And then this inside here factorizes the lead. I would have to show no work because that's what it is. So it's 3 bracket, 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 3x, x 1 and 1. All the factors of 3x squared is 3x and x. And all the factors of 1 is 1 and 1. So all signs are positive. Positive, positive. Therefore, shown. That's what it says. Solve the equation this f of x, f of x, f of g, f of g, f of g of x equals 0. So put in this equals 0. So we're solving 3 into 3x plus 1 times x plus 1 equals 0. Firstly, by that 3, it's gone. So 3x plus 1 times x plus 1 equals 0. So the product equal to 0, then it is either this factor equal to 0. And if that is equal to 0, you take the 1, transpose it as a negative 1, and divide it 3. So it will be x equal negative 1/3. Or if this factor is equal to the 0, then we would transpose this 1 and become negative 1. And so it will be x equal negative 1. So those are the solutions for that. All right. So negative 1 and negative 1. Next question. Statistics. It says student, 30 students, 30 students. Let's put a number on there. 30, so we don't forget. 30. The total frequency must be 30. All right. The 30 students took an exam. The marks scored are shown in the table. All right. So these are your marks. So this is the data x. What's your frequency f? They've given us cumulative frequency. Remember, cumulative frequency is your counting column. So we have counting the values of the number of scores you have as you go from group to group or from data to data. And it's in ascending order already. All right, it's not even in ascending order. It says compute the cumulative frequency column. So we're adding up the frequency. So if they add this to get this value. 7 plus 8 is 15. 7 plus 8 is 15. I'm just going to write it there. Yes, it's 15 plus 3 is 18. 18 and 1 makes that 19. Then 19 and 6 makes 25. So here is 25. And you see 25 plus 5 is 30. So that's how we count up as we go. All right. You see a counting column. All right. Next part now says using the information in the table, determine the range. The range is the spread of the data. The largest value minus the smallest value. Says 10 minus 1 is the range. 10 minus 1 is 9 marks is the range. 9 marks. Next question says the modal mark with the highest frequency. One that occurs most frequently. 8 is the highest frequency. The modal mark is 3 marks. One that corresponds to the highest frequency, one that occurs the most, 3. So that's 3 marks. You can see it in the tally here. It's the longest tally, all right? So 3. There's 3 marks is the modal mark, 3 marks. The median mark is the one in the middle of the 30. All right, and we can remember the formula for the position of the median. It's gonna be the ones in the middle between the 15th and the 16th. That's halfway between 30 is 15, 16. So the 15th and the 16th. The formula is the position of Q2. Position of Q2. Remember, it is half of n plus 1/3. N is 30, so it becomes half of 31. And so that is 15.5 term. 15.5 term now is the average of the 15th and the 16th term. So we could have known that without doing this calculation. 30 is an easy number to work with. So that becomes the 15 plus 16 divided by 2 terms in the middle. That we have an even number of terms of the average of 2 terms in the middle. So how do we find the 15th and the 16th term? We can go to the counting column. Counting column. This is the counting column that tells us how many scores we have as we do. All right, so we're looking for the 15th and the 16th. Now the 15th one is right here. So the 15th one is a 3. This is the last one here, is the 15th one that we want. So the 15th is a 3. So this is the 15th score is a 3. And the first of these 3 scores that takes us to 18 is the 16th. So the 16th is a 5. So we're averaging these two values to find the median. 15th is a 3, and the 16th is a 5. So the median becomes, the median Q2 becomes the 15th is a 3, and the 16th is a 5 divided by 2. That's 8 over 2, so it's 4 marks in the median, 4 marks. It's interesting that I don't see a 4 marks in the data. Maybe that was kind of delivered. As you can notice, there was a 4. 1, 2, 3, then jump to 5. There's also no 6. So nobody got 6, nobody got 4. But the median mark is 4 marks, guys, based on the calculation. Let's continue. Then I want the mean. The mean is the sum of all the scores divided by the number of scores. The sum of all the marks. So we can put in a sum column to calculate it quickly. Multiplying the score by the frequency. But it is that 3 persons scored 1. So a total of 3 marks. So let's add a sum column to it. A sum column, which is the f times x. Let's just add that in here quickly and do that calculation. All right. So we're multiplying these to what? So 3 times 1 is 3. 4 times 2 is 8. 8 times 3 is 24. And 3 times 5 is 15. Then 1 times 7 is 7. Then 6 times 8 is 8, 48. Then 5 times 10 is 50. And then this gives us the sum of fx, sum of all the scores. Let's add these up. Let's get the calculator. Do it quickly over here. Let's get the calculator. Do it quickly over here. All right. So this is at 8 right here. This is at 8. So these two are to 11, going in chunks. 11 plus 24 plus 15 plus 7 plus 48 plus 50. That's 155. 155, the total marks by all 30 students. So the mean mark is 155 divided by 30. Right? Because this 30 is the sum of f. Sum of the frequency, the number of values that it says. So it becomes equal to sum of the sum of fx divided by the sum of f. 155 over 30 is equal to 155 over 30. It's 15.16 repeated. 15, not 15, 5. 5.16 repeated. 5.16. 5.16. Using the calculator. That will be 16. The line over this is repeating the 16. That is it. 5.16 marks. The mean mark by calculation. Right? So unless I calculate something wrong here, that is the answer. Even though others are wrong, I know that I'm doing the right process, right procedure. Let's continue. This one says the two-way table shows the gender distribution of students who perform a math, students performing the math test. Says a student you're selecting from a third from everybody. Student you're selecting from everybody. All right, a student is shown that run probability that student is a female who failed the test. So that's the female column. That's who failed the test. So we're talking about 13 out of 30. 13 out of 30. That's the answer right here. All right, because they said a student, even though you're selecting from the entire population, and then you want a specific female who failed. So 13. 13. 13 out of 30. Next question. Male students, so since we're going male now, it means that we're taking from this group, so we're reduce the sample size just to the male. So a male student to show that run, what probability that he passed the test? So the male who passed the test is this 4 out of the 9 males. So that's 4 over 9. 4 out of the 9. So we'll reduce the sample space for the males, and the ones who passed the test was 4. 4 out of 9. That's the answer. 1 mark each. Nice and easy. I just done. Next one. Okay, let's look at this one now. This one says PMQROS is the cross section of a play area in a park. It says PQRS is a rectangle, and PMQ is a semicircle here. All right, that's a semicircle on top. It says O is the midpoint of down here, RS. All right, so this point divides this side of the rectangle half and half. All right, it says OP equals OQ plus 15. Then this equals 15, so that's an isosceles triangle. All right, so this length and this length is the same isosceles. Everything kind of symmetrical so far in this diagram. And also says that the angle inside is 40 degrees. All right, and inside is 40 degrees, and then 5 plus 20 over 7. Now I see this distance on this diagram, but they did not mention it up here. It's on the diagram, so we're going to use it if needs be. Just that they did not mention it. All right. So let's go. What do they want us to do? Determine the value of angle OPQ. Angle OPQ. All right. So the one this angle here. O is it ready? OPQ. That this angle here that I want. But this is an isosceles triangle. So these two angles are the same. But there are angles that are opposite, two sides that are equal. So total angle triangle 180, these two equal. So 180 minus this 40 divided by 2. So that looks like 70 degrees. It's 180 degrees minus the 40 degrees divided by 2. 180 minus 40 is 140. 140 divided by 2 is 70 degrees. 70 degrees. All right. Let's go. It says calculate the length of OR. OR is this side right here. OR. All right. So remember, we know this side is also 15. So we can find out the theorem. Nice and easy. Nice and easy. Let's put on this dimension as 15. This side right here is 15. 15 meters. This is 15 meters. 15 meters. I'm working with this side. Can kind of double check it now because this angle is 70 degrees. And I see a Z right here. It means that this angle down here also 70 degrees. And I have to for this side. We can calculate this side too. We can use the, we can find out if this dimension is correct at the dimension by using two methods of this. We're going to use Pythagoras theorem using these two sides, and I'm going to use that side. I'm going to use the angle and see if we get the same answer. Also double check. So let's use Pythagoras theorem first. Using Pythagoras theorem, the OR will be equal to the square root of the hypotenuse squared minus that 14.1 squared. Let's see what we get using this method. see what we get. And we're just gonna double check. But they did mention that 14.1 and 6, it makes sometimes make mistakes sometimes. So the square root of 15 squared minus 14.1 squared. All right, we're getting 5.12. Getting 5.12 meters. Let's use the angle now. So this is adjacent to the one. So I'm gonna say, or I want to say cos of 70 degrees is adjacent OR, what I put in is 50. Let's take this 50 and multiply it here. We're gonna get that OR becomes 15 times the cos of 70 degrees. And let's see if we get the same answer. OR equal, let's see if we get the inconsistency here. 15 times the cos of 70 degrees. See? Oh, it's like 70. It's a little bit of inconsistency. Oh, we got 5.12, now we get 5.13. So that's maybe because this side has been corrected a little bit. So what do we do? Oh boy. 5.13. So I'm going to use this answer now. I'm going to use a 5.13. As a 5.12 or 5.13. Right. If I use an angle, I'm going to get the 5.13 meters. If I use the side that I didn't mention anything about, I'm going to get 5.4. What I know for sure that the angle is 70 degrees. Because I know for sure that the angle is 70 degrees. I'm going to work with the 5.13 over here. So I'm going to put this as my answer. I'm going to use this one, 5.13, as my answer right now. The person did not mention this. Maybe that was a mistake. Maybe it was not supposed to be there, but they did not mention it up here in the questions. I'm going to work with what they mentioned. All right. Let's use sign and calculator and so again. If we didn't know this side, we're going to use sign. But this side would have been 15 sine 70 degrees. Let's see. 15 sine 70. 15 times sine of 70. See, that's why I put 0.1. Got to put in 3 to can't figure. So it's actually 14.095 something. So that's what it is. So I guess anyone you get is still correct. Anyone you got is still correct. But I'm gonna work with this. Work with that 15. But I guess anyone you work with it doesn't matter. It doesn't really matter. All right, it doesn't matter because you might have to use this anyway. So let's continue. It says calculate the area of the shaded portion of the diagram. Area shaded. So the area shaded is this triangle across the circle, semicircle. All right, and this distance that we just calculated a while ago is the radius of a circle. This distance is also, I say this is half of this length, which is the same as this. Half of this length is the radius. So it means that the OR is the radius. So we can write it up here. So the radius R is equal to the OR that we just put down there, which is, I want to use 5.13 meters. That's the radius of that semicircle. All right, 5.13. So I'm going to come down here now, and I'm going to say area shaded equals area of the triangle plus area of the semicircle. Semicircle. Now here have a triangle because we have two sides and an angle between. I'm going to use that formula. Half AB sine of the angle between them. Use that method. All right, half the product of these two sides and sine of the angle between them. That's what I'm going to use. All right, so I'm going to use half 15 times 16 and the sine of 40 degrees. I'm using that for the area of my triangle. Shift this over. you have a triangle. Let's shift this over as well. And then the area of the semicircle is basically just half of pi r squared. So I'm gonna add half of pi, which is 22/7. And the radius that we got 5.13 squared. 5.13 squared. So this is half of pi r squared. That's what this is. Half pi r squared. And this area that we use is the formula half a sine c. When you have two sides and nothing between, that's what we use here. So I'm not going to waste any time. I'm going to put everything in the calculator. I don't need to get it part piece by piece. So start it incorrectly. So this is half or 0.5. That's 0.5 times this 15 times 15 is 15 squared times sine of 40 degrees. And I'm going to add half of pi r squared to 0.5 times 22/7 times radius squared 5.13 squared. I'm going to get 1, the three significant figures, 114 meters squared. The three significant figures, that's what I'm using, 114 meters squared. All right, that is that. Next part says, find the perimeter of the cross section PQR. Oh, this is what I'm talking about. See what? PMQROS. PMQROS. Oh, so everything around it, right? So perimeter is everything around this one. Everything around the perimeter is everything around here. All right, let's add on the pieces of the diagram. Let's add, right? Let's add on the pieces of the diagram. So remember, this is 14.1. Over here also is 14.1. This is 5.13. This is also 5.13. And up here now is half of the circumference. Circumference would have been 2 pi r, so this is just pi r. Half of a circumference is just pi r. Circumference is 2 pi r. Half of a circumference is pi times r. That's 22/7 times 5.13. So this guy adding up all of those, right? 14.1, 14.1, 2 times 5.13, and then this r. So this is got it 2 times this, 2 times this, plus this. Let's write up here now with us complete. So the perimeter, right? Perimeter on. Let's make sure perimeter on. Right? Perimeter. It's 2 times 14.1 plus 2 times 5.13. Shift this over. Plus is pi r up here. Half of a circumference, 22/7 times 5.13. That's gonna give us our perimeter. Let's copy it down. But then paste it down where it is supposed to go, right? Yeah. Let's calculate everything one time. We have to do it piece by piece. Just put everything in the calculator. One calculation. Alright, that is it. Right, so it is 2 times 14.1 plus 2 times 5.13 plus 22/7 times 5.13. That's 54.6 meters. The perimeter, 54.6 meters. Done. Next part. Next question. Number 7 says the sequence question. And you see the add on this piece to that, and then add on this piece to that. Again, we're another adding on of this piece to this to get the next shape. And let's draw the third shape for us. And I want us to add it on. All right. So let's put that part in the blue. So I'm going to use the technology I have. I'm going to draw this piece up here. Trace it out and just copy it down. This is what I'm adding. These dots to the shape that is already there. That's what is being added right here. I'm just going to take this, use the technology that I have, and copy it down here. That's what you guys have to draw. Complete this section. All right, that is it. That is what you have to draw. That is the figure 4. All right, that. Next part says, study pattern of numbers. Each row relates to one figure in a sequence. Page 22, some rows have not been included. Complete rows of 1, 2, and 3. All right, so that's it. Always fill out the formula first when you can. So look at the pattern. These values there are by 4 plus 4 plus 4. So 4n start the formula. 4n start the formula. First figure actually has 5. 4 times 1 is 4 plus 1 makes 5. That's the formula for that color. Here we're increasing by 3 the number of dots, increasing by 3, so 3n. Start the formula. First figure has 5 in it. 3 times 1 is 3 plus 2 makes 5. That is the formula. And the formula will help us find other values. So, for example, when n equals 20, take the 20, drop down the formula. 4 times 20 is 80. 80 plus 1 is 81. Take the same 20, drop it on this formula. 3 times 20 is 60. 60 plus 2 is 62. 62. Is it 62? And here, I want to find this value n, you create these two things to find the value n. Here, we're going to work out when 4n plus 1 is equal to 169. Subtract 1, 4n equals 168. Divide by 4, n equals, what is that? 42. 42. So right here is 42. All right. All right. And then we want to take this 42 and drop it on this formula to get this one, which is 3 times 42 plus 2. That's what does that mean here? We're going to see this right here. We're doing 3 times 42 plus 2. 3 times 42 plus 2. 3 times 42 plus 2. That is 128. So right to 128. Take a dot. Next part says, write an equation in S, B, and N to show the relationship between the number of 6s and the number of dots D for figure N. So this is for once a relationship with the 3 of them in it, S, B, and N. So from past papers, oftentimes that they'll ask you, for example, is get the difference. Or they might ask you for the sum. Or they might ask you for a relationship connecting the S and the D alone. This time they want a relationship with all 3. So based on that experience, we're just gonna maybe add them, subtract them, any relationship, and it says an expression. So not everybody in the exam might write the same expression, right? An equation. So that the S equals 4n plus 1, and the D equals 3n plus 2. You can connect them by adding them, or subtracting them, or dividing them. right? Just want an expression. So you can, for example, do a number of things. You can add them. With the possibilities over here. So I guess any one of these, and I'm sure there are others. Can do, we can do S plus B and add them, add these two sides and add everything over here. When I add these, you're gonna get 7B, 7N, sorry. Plus add these, you're gonna get 3. Or you can subtract them and do S minus B. S minus B. So it's this one minus this one. So it's 4N minus 3N is N. And 1 minus 2 is -1. You could give them those two. You could divide them, you could multiply them. You could also substitute for the N. But this one wants a relationship with 3 terms in it. So I'll give them one of those two. Right? You could also divide them. So okay. S over B equals S over B equals 4N plus 1 over 3N plus 2. And we have multiplied them and say S times N equals 4N plus 1 times 3N plus 2. I guess any one of those approach, they will give me a mark. All right. I don't think the one where you actually eliminate the N. Otherwise, they would have said a relationship between S and D. So let me put it in purple. So if it was just S and D you want, if I wanted just S and D relationship, right? Then what we'll do is write this one and the subject of this one. And maybe you will see that there. N would be, the N here would be S minus 1 over 4, S minus 1 over 4. And the D, we should just turn a little bit. And the N from this one, we subtract the 2 and then divide the 3. So the N from this one would have been D minus 2 over 3. And because N equals this and N equals that, then we could have eliminated the D by including these two. And we will have gotten that S minus 1 over 4 equals D minus 2 over 3. And that will be a relationship, connecting. So that's if they want it, just a relationship with the sun only. All right? And we could have given them this one. I could simplify by a cross multiply. Let's do it. Let's just finish it. Multiply the 3 over here. We will get 3S. 3S minus 3 equal multiply the 4 over there. We would get 4D minus 8. And then this will come over and become a plus 3, so we'll get 3S equals 4D minus 5. Minus 5. So that's if they want the relationship with S and D only. But this is where they want S, D, and N. So one of these would be an answer. Any one of these. Choose one. One of those will be an answer. Right. Anyone. Any woman in the world. Any one of these. This or this or this or this. Anyone of them. So give them the sum, give them the difference, give them the quotient, I will give them the product. All right, good. Done. Next question says, following diagram shows a graph of this function. To give us a function. And give us the graph. All right. And I'm looking at scale. So here the horizontal scale is 1 unit to one of those grids, 2 units to one of those grids. Always try to analyze the grid before we start to work. All right, in terms of this, it is 1 divided by 5 lines horizontally. So that's 0.2, right? So 0.2, 0.4, 0.6, 0.81. And this is now 2 units here. The same number, this was 0.2. It means now that vertical is twice as much, 0.4, 0.8, 1.2, and 1.6, and then 2. So vertically, those are the small lines, 0.4. All right, let's answer the questions. Give the graph to read from it. It says, from the graph, state these things. The roots of the function. The roots are the point of the graph intersect x-axis. Roots are on the x-axis. All right, roots are points on the x-axis, x values on the x-axis, which is 1 and -2. Those are the roots. 1 and -2. So it's x equals -2, x equals 1 on the roots. Next one. The coordinates of the y-axis intersect. The coordinates we have to give the x and the y value. Coordinates of the y-axis intersect. That's on the y-axis. On the y-axis, the x is equal to 0 on the y-axis. So it's 0 something with the graph crosses the y-axis. This looks like -2. It also corresponds to the c value of the function. Right? So that is it. Give us a function that we can use it to double check, right? So it's -2, 0, -2. So 0, -2, 0, -2. This is 0, -2 is the answer for this one. This question was very nice and easy. The next one. The minimum value of the function. Minimum value is the lowest y value of the function. Lowest y value of the function. Lowest y value of the function is right down here. All right, that looks like -2. Remember, each line is 0.4, that's -2.4. -2.4. Remember where the function can double check it. -2.4, so we can calculate our xt and our yt from this and double check it. So the xt, because double checking it, and you can penalize it by double checking the answer. So the xt would be -b over 2a, that's x for a turning point at the axis of symmetry at the vertex. The b is 1, so -1 over the a is also 1. -1 over 2 times a, which is 2. Right? So in here, the a equals 1, the b equals 1, the c equals -2. So it's -1/2. And then the y value at the turning point, the yt value is 4ac minus b squared divided by 4a. And that would be 4 times a. I know I can get the yt value by just substituting this -1/2 into the function. Nice and easy. Half is an easy number to work with. So the yt would be -1/2 squared plus -1/2, and then this -2. This works out to be, this is a quarter minus, this is 2/4. Half is same as 2/4. This now is same as 8/4. That becomes 1 minus, that's 9. That's -9/4, which becomes -2.25. See, we're getting 2.4. Hey, getting -2.4. That is wrong. What they say, use the graph. So I think if you put -2.4, that to give you a marks and -2.4 based on the graph. The correct answer is actually -2.25. It's the same as -2.25. That's actually correct answer. What do you do? graph is showing negative 2.4. You see with the small scale, the accuracy is lost, but I have to show the line with thickness, but I have to draw these lines with thickness for them to show. The correct answer is negative 2.2. What do I do to the correct answer? Minimum value. The question says use the graph and see that's it from the graph. Correct answer. I'm gonna put it negative 2.25. Graph is negative 2.4. Graph is negative 2.4. This is the correct answer. We'll put negative 2.25. This is the correct answer. I think if you put this, if you penalize just still enough, that is the correct answer, but the graph is showing us this. Because I have to draw the line with thickness for it to show. Right? If the line has 0 thickness, you will see that it will show at negative 2.25, or it's a different scale. But I think most people are going to put negative 2.4, and they will give you a marks. They put 2.4. Okay? So this is still the correct. But this is the actual correct answer. Then it says the equation of axis of symmetry as XD value and X equals the XD value of here that we got minus half, which also corresponds to the vertical line through the vertex here. See there, the vertical line through here. Right through here, which is right halfway between the 0 and 1. I think it is 0.5. Negative 1, negative a half. X equal minus half. That is it. So I have a right of an equation. X equal minus half. Minus 0.5. That's substitution. Next part says on the pair of axes, you can draw and label the line y equals 2x plus 4. So we draw that line. It's going to be easy. But you know why I see intercept and rise and run 2 units. 1 is the rise and the run. So y-axis intercept is 4 and the gradient is 2. Gradient equals 2/1 in rise 2 run 1. Go to other points. So rise 2 run 1 takes us to here. Rise 2 run 1 takes us to here. It's plus 4 themselves. Let's see, plus 4. Right, plus 2x plus 4. 2x plus 4 is. So let's make sure. Let's show. So the y-axis intercept is 4, and the gradient is 2. Oh, and see the mistake I'm making. This is not 2, you know. See, I have to rise 2 units, not 2 grade. Right. Rise 2 units. From 4 to 6 is 2 units. So starting here. Rise 2 units. That's 2 units. Run 1 unit to here. Not a grid. Rising 2 units. Running 1 unit, not grids. Rise another 2 units. Run 1. Rise another 2 units. Run 1. So you see, that point is on the graph right here. This point is on the line. Let's go the other way. Could go the other way too, you know, could rise negative 2, run negative 1. Go the other direction. Could rise negative 2, run negative 1 to here. Rise negative 2, run negative 1 to here. That also is a point on the line that we want. We have enough to draw the line. We have enough to draw the line. All those points that we can use to draw the line. So this color draw a straight line through those points. Now, these are points on the line I'm doing right here. Use the ruler and just draw that straight line. Don't draw it freehand like me, please. Looks like it passed through all these intersections there. That is that line. Y equals 2x plus 4. I'm sure they're going to ask us about these 2 points will intersect the graph. This point is where x equals 3. This point is where x equals -2. That's just how these questions are, guys. Every time that's what they do. So just know it's coming. When you practice and do all of the papers, you know what's coming next. That's just how they set this question. See? It says use the graph, determine the solution for the pair of simultaneous equation this. And I want the solution. Wow. So it means that I want the x and the y value. The x and the y value. So just put on the x value alone. You are wrong. You want the x and the y value. So let's go back and put the x and the y values. This point is actually 310. This point is 310. Y equals 10 at that point. This point, y equals 0, only y equals 0. So it's -2, 0, and 310. -2, 0, 310. -2, 0, 310. That's the solution. -2, 0, and 310. I can double check if this is correct. Take the 3, plug it in there. You get 2 times 3 plus 4 is 10. Good. Plug it in this one. You're gonna get 3 squared is 9 plus 3 minus 2 divided 10. Good. The 310 is good. And then the -2, well, the -2 is already at that. -2 here. So those are 2 points. Nice and easy. Next question says, the following diagram shows velocity time graph a car's journey from town R to town Q. The car accelerates for 2 minutes. 2 minutes. This is time axis is in seconds. That 2 minutes, be careful now, it's actually 2 minutes, 120 seconds. All right, 60 minutes a second. So this is it. This is it right here. 120. It accelerates up to 30 meters per second in the first 2 minutes. All right. So it says the car accelerates for 2 minutes, travel at a constant maximum speed. That's up here. It went at the maximum speed up here. And at a constant maximum speed of 30 meters per second. Then slows to stop. Slows to a stop. So this is when it's slowing to a stop. All right. Let's answer the question. It says, determine the initial acceleration of a car. Acceleration equals gradient, or the rising gradient. Rising gradient, or the rise gradient. Acceleration is the rise gradient. Speed is increasing. Which is equal to the rise over the run on the graph. Now the rise is 30, and the run is 120 seconds. We work in seconds. You cannot put the minutes. Meters per second, the time must be in seconds. So it's 30 over 120. This is 30 meters per second over 120 seconds. That is it. Bam, bam, 1/4. 1/4. 1/4 meters per second squared. 1/4 is 0.25 meters per second squared. That's the acceleration there. All right, next part says calculate the distance traveled. Calculate the distance. Calculate the distance between the 2 towns. 2 towns. So this distance between the 2 towns is the area under the graph. As area under the graph is distance traveled. So the area under the graph, the distance between the 2. Because what the question saying, it's a travel between town and that, and it's gonna stop at R. When it stop again, it's gonna reach R. Q, I mean, stop at Q. Starts at R and stops at Q. So the area under the graph. So that trapezium, that's right on the side of the trapezium. All right, so wow. So this is what now. This is what. That is what. It's halfway between 560. Okay, I'll check it now. Everyone is 60 seconds. 60 seconds. All right, 60 seconds. All right, so then it's 600. 600. Right here, 600. All right, here is 120. This side is 600. This side is 600 minus 120. Just right. You find the length of the side. It's 600 minus 120 parallel side. So minus 100 first you get 500, that's 480. 480. Equal 1, 2, 3, 4. No, not that. Doing this one. 1, 2, 3, 4, 5, 6, 7, 8, right? 6, 8, 48. And then now this side is, this time between them is 30. This is 480 is one side. This is what out here, so is 60 more on this. 60 more on that is 840. What it says 840. That's the length of this side. 840. Right? 840. So it's half of 480, 840, and the 30 is the distance between them. All right, those are the dimensions that we're looking for the distance traveled. So that's what I did here. So distance equals area. So trapezium is half the sum of the parallel sides, the 480 and the 840 at the parallel sides, and the distance between them is 30. That's a calculation. And even we calculate an area, distance is still in meters. But units cancel one another. Meters per second, right? The meters per second cancels the seconds to give you meters. Right? So let's go. It's here, distance travel. This is it right here now. We're doing this calculation. So as I was saying, these two is time in seconds. And this is meters per second. The seconds cancel the unit of meters. So if you calculate the area, the distance is still in meters. The area, the result is still in meters for distance. All right, so that is that. Right here. So hope you all did this calculation correctly. 4, 4, 5, 4, 1, 4, 1. I'll put some of the parallel side. 0.5 times bracket 480 plus 840 close bracket times 30. That's 19,800 meters. 19,800 meters is the distance traveled. Next question. Or over here, section 2, or 2 questions there. This question says a ship sailed from port A, give us port A down here, to port B, which is 15 kilometers from A on a bearing of 042 degrees. The 042 degrees must be inside here. 042 is clockwise from the north road. So this is 042 degrees here. 042 degrees. 042 degrees. And they go 15 kilometers, right? 15 kilometers. This is 15 kilometers. 15 kilometers. And right here is B. They didn't show it, but right here is B. That's down B right there. It says the ship then sails to sea. So from here now it goes to sea. 1900 kilometers. So down here must be sea. Down here must be sea. And it goes 19 kilometers. This is 19 kilometers. And it goes on a bearing of 130 degrees. So clockwise from the north line here is 130 degrees. That's the bearing. Clockwise from the north line, 130. All right. So the following diagram shows a sketch of the ship's journey. That is it. It says on the diagram, insert the bearing of 042 right here and 130 right there. So I've done that. I've also added those distances. All right. We don't have an angle inside the triangle yet. And this angle inside there will be very helpful in finding this side. Because then we could use two sides and angle between cosine to do at this side. So I'm sure we're gonna need an angle there. Okay, I'll find an angle. Multiple ways. You can extend this side like this. And then say this is your Z angle down here. So this angle is 42 degrees. The angles are equal. And then on this side, total on a straight line is 180 degrees. This is 130. So right inside is must be 50 degrees. And so the total angle across here, bring up this line a little bit shorter. So extend this north line down and put the Z angle on the straight line. And so the angle inside here that we want is put a different color. That will help us simply equal to 92 degrees. That's the easy way to do it. A lot of persons would work out this angle first by saying that these two are co-interior. Work out this one and do 180 degrees minus the 42, and then so total angle around here is 360. That is more work, guys. More work. Do the mathematics the easy way. All right, extend that line down, break this angle that we want. See the Z angle on one side, that's 42. On the other side, total on a straight line is 180. Do the mathematics the easy way. All right, other way to work as well. In the case, the angle between here is 92 degrees. We know we're going to need it. That's just how these questions are. Let's calculate it first. We know we're going to need it. Question says, calculate the distance between the two dots. See, they didn't ask for it, but you need it. Between here and there. There's cosine rule you have to use. All right, cosine rule. So remember, cosine rule starts out like Pythagoras theorem. They subtract a piece. When you use cosine rule. All right, and so the side over here is c squared. It's equal to, like Pythagoras theorem first, 15 squared plus 19 squared. 15 squared plus 19 squared. That if this was the right angle, that's what it would be. So we'll subtract a piece. We subtract twice the product of the two sides. And the cosine of the angle between them is 92 degrees. And instead of putting a square on this, I would square both sides. And so I can drop this square and just drop this square, and square this side over here. So let me just shift down some stuff a little bit. Create some more space. One. So instead of putting a square on this, I'm going to remove that square and square root everything. Put that in the calculator and we will have our answer. Quick and fast. So that's a square root of 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of the angle between them, which is 92 degrees. That's 24.6. Give 3 simple figures. 24.6 kilometers. And define it, put on the diagram. So this side is now 24.6 kilometers. 3 simple figures. Let's see if we put in those figures right. 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of 92. That is 24.6 kilometers. Next question said determine the bearing of A from C. So always note that the bearing is taken at the from position. So it's from C to A. So the bearing must be measured at C. So the clockwise angle from the north line at C from position. All right, diagram kind of small. We want the bearing at this angle here. So we want a clockwise angle from the north line around here. That is the angle over this angle. And always say the angle inside the triangle will play a part in the calculation. All right, angle inside the triangle here will play a part in the calculation. So because I know that I'm going to call alpha from now, it always plays a part in the calculation. Trying to find out the red angle. How will that play a part in the calculation? It will play a part in the calculation. Can do this. All right, so I think we're going to need this angle here. This angle here, we're going to need it as well, which you can find it from this. Practice 15, look how it's 50. I'm sure it's 50 by acid as well. But this is come down this side, up this side, and down this farther side. So this angle equal 50 degrees. Z angles. You could also go 4 interior. These two angles are 4 interior angles. They are up to 180 degrees. This angle is 50 degrees. I don't want to show the diagram. This angle inside here is 50 degrees. This angle is 50 degrees right here. And so this angle theta is called theta, so reference. This bearing angle theta is going to be 360 minus 50 minus alpha. 360 minus 50 minus alpha. So we need to find the alpha. We're going to find the alpha using cosine rule. We'll just find it on the screen here and then copy it down. Right inside here. Cosine rule. No, not cosine rule, sine rule. Sine rule. Sine rule for alpha. So we're going to use angle and side opposite. Angle and side opposite. All right. So it's going to be sine of alpha. Let's do it here. I know, let me do it on the right side of the screen. And then I'll just copy it over. Let's do it on the over here. Let us copy it over. So this is in front of us. Diagram. All right, let's do that. Let's do it like this. Let's do it like this. Let's do it like this. All right. The angle that over theta. The bearing angle is theta. That's saying bearing angle theta is going to be 360 minus the 50 and minus the alpha. And the alpha one use sine rule to find it. Sine rule. So you're going to be sine of alpha over the side opposite. Start with what you want to find. Sine of alpha over the side opposite alpha is a 15. Equals sine of the angle that we know. Angle that we know is the 92. Over the side opposite the 92 is 24.6 that we just found. And then we're going to take the 50, multiply it up here, and then inverse sine. So we're going to get alpha equals sine to the minus 1. The 15 is going to go up there, multiply. So that's sine to the minus 1 of 15 sine of 92 degrees divided by 24.6. That's what we're calculating for alpha. All right, let's get the calculator. 1592, 20. So we're going to do sine to the minus 1 fraction 15 times sine of 92 over the sine of 92, which is 24.6. That gives us 37.5 degrees. Let's just call it 30. Remember, bearing is given to 3 digits. So let's just call it 30 degrees. That's right, 38 degrees. Uses angle back up here. And so the theta that we want becomes 360 degrees minus 50 degrees and minus 38 degrees. Theta that bearing angle equals. So it's 360 minus 50 minus 38. 360 minus 60 minus 38, 272. 272 degrees. 272. 272. That's not the only way to do it, but that's a good enough way. Let's copy this over. Put that piece. Put it down here. Let's paste it inside here. Fit it in there. All right. Two of them is it. That's an easy. Sparse. Circuit theory. All right. Question says LM and P line of circumference of a circle whose center is O. Line NP right here. Let's get it right. Line NP. Line NP is a tangent. Once it's tangent, you're thinking tangent and radius is 90. Tangent and chord is that the angle between tangent and the chord is equal to the angle subtended by the chord at the circumference of the ear. So right now, this angle is theta, then this angle is theta too. Angle between tangent and chord equals the angle subtended at circumference and internal segment by that chord. And it says OMN is a straight line. That's a straight line out here. So this is a triangle. And it's a right angle triangle right now. All right. It says the line PL is a diameter. So this is a diameter of a diameter subtends 90 degrees at the circumference. So this angle is 90. Take out those lines. That angle is 90. Diameter subtends 90 degrees. This diameter subtends 90 degrees. These basic things you must know on the side. Then this angle down here is 24 degrees. That diagram. Question says, carefully develop each of the following. Show detailed working where necessary and give your reasons. What your answer? Angle PON. Angle PON inside here. So I'm going to come and work in this triangle. This angle is 90. And so these two angles must add up to 90. But that's a triangle. Total angle triangle is 180. In a right angle triangle, these two angles are complementary. They add up to 90 degrees. So this angle becomes 90 degrees minus 24 degrees. So that is 70 and minus 4 more make 66. 66 degrees. All right, and let's give a reason. So first I'm going to tell them that this angle here is 90. So I'm going to say that's because angle OPN equals 90 degrees, which is the angle between tangent and the radius. And then when that is 90, then these two angles are complementary. Our total angle in this triangle is 180. Total angle in triangle, which one is? OPN. OPN. OPN is 180 degrees. That's my reason. All right, so this angle up here is 66. Put on the diagram, right angle is 66 degrees. This angle right here is 66 degrees. That you find it put on the diagram. Well, that's an angle at the center, obtained by this chord. So same chord obtain this angle up here. So this angle is going to be half as much, 33 degrees before you even start. You know that is so. Angle at center is twice angle at circumference. Better than answer that one. Better. Angle PLM. Angle PLM. There you go. Angle PLM is half of one the same. Both of them obtained by the same chord. Angle at center is twice angle at circumference. So this is equal to half of the 66 degrees, which is 33 degrees. Because angle center of a circle is twice angle at the circumference. The one at the circumference must be half the one at the center, right? One at the center is bigger by 2. All right, next one I want is angle PMN, angle PMN, angle PMN, angle PMN, PMN. That is this angle here. All right, so if I focus now on this triangle right here, I'm trying to find this one. So I know this already. If I can know this one out here, then that'll be nice. Now this one is angle between the tangent and the chord. And the chord is something 33 degrees up here. We just worked out. Did I erase it? Did I put it in there? 33 degrees. And so this angle is 33 degrees as well down here. But the angle between the tangent and the chord equals the angle subtended by the chord. So this angle is 33 degrees. Let's step out these lines. That angle is 33 degrees. So it is equal to the angle between the tangent and the chord. And angle is equal to the angle subtended by the chord. So this angle is 33 degrees. And then now, this angle that we want over here is going to be 180 minus these 2. The total angle in that triangle is now 180. This one is going to be 180 degrees minus the sum of 24 and sum of 24 and the 33. It works out to be what? Works out to be 180 minus 57, which is 123 degrees. 123 degrees. That's not all we did it. I'm sure there are multiple other ways to do it, but good enough for now. 123 degrees. All right. I can leave that on the diagram and just put the answer down here. So see diagram. I'll make explanation down here. 2 marks for that. And put the diagram, put that information in the diagram as the C diagram. I'd have to indicate why this is 33 degrees. All right, so let's just show the work. So let's do it. I'm going to tell that I'm at MPN equals 33 degrees first. MPN equals the same 33 degree that we just found at the top. Same 33 that we just found. Was angle between tangent and the chord equals angle subtended by the chord at the circumference in that turning segment. And then after that, total angle in triangle is 180. So total angle in triangle is 180. So maybe smaller, let's make it smaller. That's a bit more. I want to say also total angle in triangle, triangle we're talking about is PMN. PMN. Total angle in triangle PMN is 180 degrees. That's what I'm going to want, which is PMN is 180 degrees minus the sum of the 33 degrees and the 24 degrees that are there. So what we get? We got 157, 123. Where I get 57? That's right? Yeah. Oh, that was 57, 123. Yeah, also subtract 57. Yeah, 123, 123, 123. 123 negatives. That is the question done. One question to go. One question to go. Let's go. So in diagram below, OPQL is a parallelogram. This is a parallelogram. And like parallelogram questions in vectors. Because I know right off the bat, opposite sides are equal vectors. So OP is R here. So this over here is also R in this way. This vector is also R. We can populate the diagram. This vector across here is S. So it means that vector here is also S, right here. It's also S. Right? So then it says T is a point such that PQ, that's this length, is equal to QT, that's this length. So it's same straight line, holding here, same straight line. That means that this point is just the midpoint. And so this length and this length is the same, direction is same. So the vector out to S, out to Q, the vector out to T from Q is also S. Same length as this, same direction, equal vector. So this vector out here is also S. That's right, that is a good point. That vector is also S. Then it says the point M divides PL. This point M divides PL ratio 2 to 1. So this is 2 parts, this is 1 part. 2 parts, 1 part. So the total parts on the line is 3. I mean that this part of the line is 2, this part is 2/3 of the whole line. 2/3 of the whole line. And down here is 1/3 of the whole line. All right. I'm going to need those ratio numbers on the diagram. 2 parts, 1 part. It says find in terms of R and S the vector PL. P to L. Clear on the diagram, or do we go over from P to L? So from P to L, we're going to come out to Q first with the S. And then we're going to go from Q down to L minus R. Why is it minus R? We're going in the opposite direction to that. I'm going this way. Right? So this answer is simply S minus R. S this way minus R takes us from P to L. So we now know the vector across here is this S minus R. All right. Next part says OM. How do we go from O to M? From O to M. Easy. Come up to S first, come up to P first with the R, and then go P to M. Where the PM is 2/3 of the PL. Let's set it up. Let's write it up on the screen and then copy it down. So I'm going to say to go from O to M. I'm going to go O to P first, and then I'm going to go P to M. All right. Then now the PM right here is 2/3 of MS. So this becomes OP plus 2/3 of MS. 2/3 of not MS, ML. ML. This is ML. 2/3 of PL. PM is 2/3 of PL. 2/3 of PL. All right, I don't know PL is this. I can put the calculation down here. Put some space down a little bit. And right. Then now let's just finish it here. So the OP is R. So that's R plus then 2/3 of PL is 2/3 of that. So from 2/3 of this part, 2/3 S, and then 2/3 of the minus R is minus 2/3 R. If we consider these 2 R values, this becomes this only 2/3 S right there. 2/3 S, and R minus 2/3 R is 1/3. Becomes 1/3 R, and that is your vector OM right now. That is your vector OM. Put on this down here. That is the vector OM. All right, that is OM right now. Then it says prove that OM and T are collinear. OM and T. So prove that OM and T are collinear, but this is OM, right? We need to use two vectors between the 2 points, between 3 points, and show that they are parallel. We have one already, OM. So I'm using OM, which is 2/3 S and 1/3 R. 2/3 S, 1/3 R. And we need another vector. Look at the diagram and see what we want. Either we need OT or OM. No, we have OM already. Either we need OT or MT. Either OT or MT. We have to use a vector OT in it. No, which one is easier to find? All right, an easier one. So is either MT or OT. Now, OT is much easier to find. I don't have to calculate anything. OT is this R plus this 2S. You can see it on the diagram. R plus 2S. Just that. No work needed. So you don't have to calculate anything. So you calculate, you're wasting time. So one of those, instead of using, if you're using MT, you have to calculate. OT, you don't have to calculate. You can use any two vectors. There's R plus 2S. So we want to use OT, which is R plus 2S based on the diagram. Since this has the S in front, I want to write this other way around and put 2S plus R because we want to now compare these two vectors. These two we want to get one at a month for the next. What do we do? Get rid of the fractions out of this. Why? Because fractions make it more difficult to see the relationship between the vectors. I'm going to take this one and multiply 2 minus 3. And that will eliminate the fractions from it for us. Multiply this by the 3, you're going to get 3OM equal multiply this by 3, cancel this 3, gives us 2S. Multiply that by 3, cancel the third, we get R. Then you see that this and this is the same right now. Therefore, this 3OM equals that OT. I can say OT equals 3OM. So we can equate two vectors. And so we're going to write now, it's between purple. OT is 3OM. OT equals 3OM. And you have now have one vector that multiply the next. And then additionally, there is a common point O. And so we have the conditions we need for collinearity. One is that you have parallel vectors. OT, let's zoom it up. OT is parallel, that's the symbol for parallel. 2 OM, because we have this multiple, one is a multiple of the next. And the second thing for collinearity is that there must be a common point, which is O. O is a common point. Because you have those two things that mean, we can draw a conclusion and say, therefore, points involved O, M, and T are in fact collinear. That is it. Right? Nice and easy. And so we'll come to the last question on this paper. It says 3 matrices A, B, and C are such that that's A, that's B, that's C. That's a 2 by 2. That's 2 by 2. That's a 2 by 3 columns, 2 by 3. This also is a 2 by 3. That's what we have. It says find the matrix A, B plus C. So we're gonna have to multiply the A and the B first, and then add the C to it. All right. So let's write it over here. So the AB is a 2 by 2 times a 2 by 3. 2 by 2 times 2 by 3, which is possible because the number of columns here, number of rows here are equal. And the result is going to be a 2 by 3. That's going to be the result. The order of the resulting matrix is going to be a 2 by 3. We're going to calculate the AB first. I mean, add the, and then add the C. All right. So, yeah, set the close to we can do AB plus C. So let's do it this way. So the AB, I'll put the plus C over here. The AB may multiply these two. So it is the 3, 2, 5, 4, and the 4, 0, 2, 3, minus 1, 7. And then we're going to be adding the C, which is the 4 minus 1, 2, 7, 3, negative 5. All right, so let's do this. Spin is giving me hell. Spin is giving me hell, guys. Let's do the multiplication now first. Now remember, we multiply matrices that multiply the rows of the first matrix by the columns, and there are 3 columns. And let's write out the resulting matrix first. The resulting matrix, we're going to have those values in it. Those are the placeholders for the resulting matrix. So just need to write this again. All right, so let's do it in there. So the first value here is positioned in the first row and the first column. So to get to multiply this first row by this first column. So it's 3 times 4 and 2 times 3. That's first element times first element, second element times second element. First element times first element, second element times second element. It's 3 times 4, which is 12, and 2 times 3, which is 6. So the text value here is positioned in the first one, second column. So multiply this first row by this second column to get it. Again, it's first element times first element, second element times second element. First element times first element, second element times second element. 3 times 0 is 0. 2 times minus 2 is negative 2. And the last value out here, move this bracket a bit. Last value out here that we want is in the second, is the first row's third column. First row, third column. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 2 is 6. 2 times 7 is 14. All right, so I'm going to put the bracket now, right here. Button blue. All right, ready now. This value here is positioned in the second row and the first column. So we get to multiply this second row by this first column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 4 is 20. And 4 times 3 is 12. The value here is positioned in the second row, second column. So to get it, multiply this second row by the second column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 0, 4 times negative 1. 5 times 0 is 0. 4 times negative 1 is negative 4. But the last value out here is positioned in the second row, third column. So multiply this second row by this third column. First element times first element, second element times second element. First element times first element, Second element times second element. 5 times 2 is 10. 4 times 7 is 28. Let's move this bracket again. We're adding these values. 4 minus 1, 2, 7, 3, minus 5. All right, and we can write the final answer. Let's make this a little bit smaller. This is limited. I'm just going to write the final answer down here. Because this is 18. 18 and 4 is 22. I didn't know it. This is -2 and this is -1. -2 and -1. Well, let's include that. And then that's it. Right. So the 0 minus 2 is -2 and -1 is -3. -3. This is 20 and 2 makes 22. And this is 32 and 7 makes 39. This is -4 and 3 makes -1. -4 and 3 makes -1. -1. So finish. Then this is 38 minus 5. 38 minus 5 is negative. 38 minus 5 is 33. 38 minus 5 is 33. That is the answer there. We'll come to this one now. It's what's the inverse of A. This is A again. A is the matrix. 3, 2, 5, 4. 1 inverse. The inverse, e to the minus 1 is 1 over the determinant of E and the adjoint of E. That is 1 over the determinant. This product is 12 minus this product, 5 times 2 is 10. Multiply by the adjoint. Interchange the elements on the first diagonal. 4 goes here and the 3 goes there. Leave these two other elements where they are, but change the sign. This case where it is change the sign to a -2. This case where it is change the sign to a -5. This one there is just a 2. So really, we're taking half of these values now, but the 12 minus is just like 2 under here. The determinant is 2. And so we're halving those values. So this becomes equal to half of 4 is 2. Half of -2 is -1. Half of -5 is -2.5. I could put 5 over 2. Half of 3 is 1.5. Let's shift this -1 a little bit more to the right. And then close that bracket. That is the inverse. Question says, write down the 2 by 2 matrix to represent the matrix product. A times e to the minus 1. A times e to the minus 1 is equal to identity matrix for multiplication. I. And I is a matrix 1, 0, 0, 1. The number, the matrix that B is just like the number 1. This don't need any calculation. And that is it. End of this test. That is that. Is that. And this was a nice and easy paper. Nice and easy paper. In one question that some persons might miss a little bit. This one that asks for interest. Right here, I think a lot of persons want to get with the E, I think that is the answer. All right, that is it, guys. That is it. Share this in the group. Grade yourselves and tell me what are they afraid to do it in a box. I think if you know where you are at this stage on this paper, then you will know what you need to do on the multiple choice to come, and you will be accordingly. All right, what it is. All right, guys, I'm gonna end it now. Okay, bye. I'm gonna end it now.